All right, good afternoon, everyone. First of all, I'd like to thank you to come see me instead of Etsy down the door. The good news is my talk is on a full hour, so you'll be able to get out of here earlier. So this is what we're going to talk about. This is a graph from a breaking news event that happened on February 11th of last year when Miss Houston died. And this graph indicates or shows about a full day's worth of traffic. And that huge big spike is when the news broke. And we're also going to talk about scheduled events. So how do we deal with managing our traffic or trying to predict traffic levels for events that we know are going to happen in the future? In this example here, it's the Winter Olympic Games that are coming up in February. Of course, without your website going down at all. So I used to be the team lead for a group of 7 sysadmins at CBC. I since moved to a different department. I've been with them for 11 years, so I've seen all of the mistakes that we've made and how we've improved them. If you don't know, CBC is Canada's public broadcaster. It's kind of like a combination between NPR and PBS here in the United States. The main difference is that we're funded by taxpayers as opposed to donations. So in Canada, this is known as a crown corporation, where we're technically owned by the Queen of England. So she's our boss. Because of that, we have a mandate to serve all Canadians and to produce Canadian content. So here's an example of our website, specifically the news portion of the site. So we're like, the BBC, but for Canada. Journalism is one of our core businesses. Producing radio and TV shows is something else that we do as well. So in order for you guys to understand how we got to where we are today, I need to give you a little bit of a history at our company. So we need to go back in time before the invention of the iPad, before Android was invented, even before the iPhone, Twitter, YouTube, even before Facebook existed, to the ripe year of 2003, when a smartphone looked more like a calculator, and I don't know, an iMac was kind of like an egg. It was egg-shaped. But the important thing is that this was the year that we realized at our company that the internet wasn't a fad anymore. This wasn't a tool nerds used. This was a serious medium, and we at the company decided to expand and create what was called a new media department. And this department was responsible for producing content online. We hired a bunch of Java developers, a bunch of DBAs, and we created a new department that wasn't television and wasn't radio from scratch. And the first requirement that came out of this from management was news stories have to appear on our website as fast as possible. We have to beat our competition. We have to beat our competition online. So how do we do this? Well, we figured, all right, let's make the story presentation engine dynamic. Let's make it database-driven in the back end with the J2EE front end. So at the time, the enterprise-level database to use was Oracle. This worked well for a bit. And then later that year, we had a provincial election in the province of Quebec. It's the second largest or second populous province in Canada. And as part of the offerings that we gave to the Canadian public was real-time stats of polling stations, of who voted for which party and when, as well as relative news stories or related news stories to the election. So the polls closed at 9 p.m. That night, and as soon as it did, this happened, of course, right? We peaked at about 150 hits per second. I mean, that's nothing, especially even for 2003 numbers. So we realized that at this time, back in 2003, this architecture didn't really work for a news website. especially in a situation where most of the content or most of the requests are read-only. So why do we need a database to power a read-only website? There was no commenting back then. Nobody was voting on anything. It was just to consume content. So we need to go back to the drawing board essentially and simplify our infrastructure and presentation model. Running a dynamically generated news website in 2003 wasn't very scalable. So let's take a look at some other typical traffic patterns that we encounter during breaking news. So this example was the most recent one that I found. Was when we called it the royal baby in Canada, when Kate had her baby. And as they announced the birth, we jumped from around 12,000 hits per second to 30. Boston Marathon in bombing in April 15th of this year. Same example, but instead of hits, I decided to illustrate traffic. So from 1 to 2.5 gigabytes per second in about 7 minutes. And then, of course, Whitney Houston, as I opened with, 1 gigabits to 14 gigabits per second in about 10 minutes. So one thing that you'll notice with all of these graphs is that it's short-lived. It's a huge spike, and then it just tapers off within 30 minutes or so. People come to the site, they say, hey, great, so-and-so died, or so-and-so, something happened, right? I got my fill, I'm done, and they leave. So how do we build out an infrastructure to handle this type of traffic? Spiky, relatively short-lived traffic. Well, we quickly realized that it was too expensive to build out infrastructure to handle traffic levels that are only sustained for less than 1% of the year. So those spikes, it would be ridiculously expensive for us to be able to build a huge data center to handle spikes of 40, 50, 60,000 hits per second if they only lasted 15, 20 minutes for the entire year. And of course, the servers would be just sitting there idle for the majority of the time. We also needed to make sure that our content was flexible to changing traffic conditions while still maintaining functionality that users expect. So what I mean by this is that if there is a breaking news event and someone wants to know what happened, they don't care about all the other cruft that you're trying to sell on the website. They don't care what's going to be on CBC News that night. They don't care about advertising. All they want to know is what happened. So the journalists wanted to be able to say, hey, you know what, let's change the way the site looks so that when people come, they know exactly what the breaking news is, and they don't have to hunt and peck to try to find what's going on in the world. And of course, we have valuable information that users need in a crisis. During incidences, we post information about the Red Cross, how to get in touch with your loved ones. So this is definitely an essential service that Canadians abroad especially need to have access to. And then of course, we still have to make sure that our sites appear as quickly as possible on the site. So we can't have very, very long cache times. So we decided to start from the ground up. And the first thing we did was get rid of this. Get rid of the J2EE front end, get rid of the Oracle database for news presentation, and save everything to disk. Internally in the organization, we call this baking. So we bake out the files, we bake out the output to a file store. And it has a few advantages that we discovered. The first, it observes the principle of least surprise. So what I mean by that is that if I go to cbc.ca/news, I know that index.html is going to be in the document root for /news. Right? I don't have to go and learn SQL to search through a database to find where that index page is. Serving content from disk is fast. It takes advantages of operating system and file system caches. And it allows us to turn off site features easily. So we don't have to do a release of a WAR file. We can just go in, edit the HTML page, save it, and we're done. So I'll give you an example of how we do that. Each colored section of this page is controlled by a separate HTML file. they're included or they're assembled together using server-side includes. So yes, even in 2013, we still use server-side includes. So for example, if a journalist decides, you know what, I want to get rid of the green and orange sections, we can do that so that the core, the most important piece of information is displayed right away. One other option that we can do is we can put a notice on every single page by editing one page. So usually we say if there's breaking news or high traffic, we have a notice at the top, like a banner that says, "Hey, breaking news, come to this page to get more information." And all we need to do is just edit one page for that. SSIs are primitive, but they're fast and secure. So by that I mean we still publish stuff through a content management system, but the CMS just outputs the snippets of data that are included using SSIs. We have one template file that we can edit to change the look and feel. And all pages are updated instantly. And this was a challenge that we had. The news department doesn't want us to delete anything, right? Even stories they've written 15 years ago, they still have to be accessible on the site. But they also wanted it to be, whenever we did a site redesign, they wanted those old stories to have the new look and feel. So being able to have this templatized architecture, we can just go ahead and say, hey, you know what? We've updated this site to a new design. All we need to do is change the template file, and all pages, no matter when they were created, are automatically updated. Without having to, we don't have to wait for a CMS system to write out the new files. We have over 800,000 news stories. So to get a CMS system just to go ahead and say republish 800,000 stories will take quite some time. So we decided to also use a content delivery network. Now, we had been using Akamai since 2001, but it wasn't until around 2003 did we seriously start looking at using it properly. But I'm sure, nowadays there's so many other CDNs you can use. And what we decided to do was to leverage conditional gets. And the importance of using if modified since requests is kind of, how can I say this? If you know your content's not going to change, then you can set a really high cache time. So, your logo, your images, they hardly ever change, so you can say caches for days or weeks. But news content, because we have to publish this as quickly as possible, what we've decided to do is set a low TTL, set a low cache time, but rely on the fact that the CDN will always come back and say, hey, has this page changed? Has this page changed? Using if modified since requests. And this is essentially, as I'll talk later on about it, but this is the magic sauce that we've discovered, in the sense that we can offload a ton of hits based on the fact that we take advantage of if modified since requests. So the body content is never sent, on every single request, but if the page does change, then a fresh object is delivered to the CDN or to the cache. Here's an example. So let's say we have a TTL of 30 seconds, and if the object was last modified, January 1st of this year. One thing that we discovered at least with Akamai, is that a TTL doesn't automatically expire the object in cache right away. It just marks it as invalid, or just invalidates it. So the cache will still come back and say, hey, has this object changed, even though the TTL is expired? If that wasn't the case, then after 30 seconds, every request would come back to the origin, and we'd all have to deliver, a 200 status code moving forward. But because the CDN says, hey, you know what, I'm just going to check after 30 seconds if the object has been updated, then we just send back a 304 not modified without the payload, saying no, it hasn't changed, or if it has changed, a 200 modified and then the payload. So the reason why we have 30 seconds, the reason why we have TTL in the first place is just to sort of protect us from all of these requests. Because it's still a one-to-one request. Every time a user makes a request for a page, it still goes back to the cache. The cache still has to come back to the origin to see if it's been updated or not. But within that 30-second window, the CDN won't come back to the origin. And the journalists seem happy with that. If they make a change to the page or to a news story, 30 seconds is an acceptable time. So here's another graph to illustrate this. This is the number of, the types of status codes returned by our origin. 75% of them are 304 not modifieds. So our content doesn't change very frequently, and this allows us to save a lot on bandwidth, which I'll talk a little bit more about. One other thing I wanted to note was to make sure that obviously we use last mile acceleration, as Akamai likes to call it, or gzip compression, as you and I like to call it. As you know, HTML, JavaScript, CSS compresses really easy. So you can definitely increase your performance by using this. Persistent HTTP connections. So the purpose of a persistent HTTP connection is to try to save on setting up and tearing down TCP sessions. So in this case, the CDN will connect to us, keep the connection open, and any subsequent requests will go over that same TCP connection. One thing to note is that, or at least one thing we did at CBC, was we set our persistent connection timeout to 1 second higher than the CDNs. And the reason why we did this was to ensure that the CDN kept control of the TCP session so that we weren't tearing it down before the CDN was expecting it. So by default, Akamai has a 5-minute or 300-second TTL, or persistent connection timeout. We set it to 301 so that if Akamai wanted to terminate it, they can, but we weren't going to shut them down ahead of time. In cases where we weren't delivering news, we decided to organize our file system based on TTL. So for example, we have a lot of webcams. Webcams were huge back in 2003. So we said, if you guys have a webcams, put it in this particular folder, and that folder was set to have a TTL of 5 minutes. And we tried to keep it simple that way so that users also expected where or how long their object was going to be cached for. And that really helped with requests that we're getting. A lot of people were asking, hey, can you purge this from the cache? Can you purge this from the cache? And that was essentially flooding our system in desk, and everyone was just asking to update the cache. So we decided, hey, you know what? If you put your object in this file or in this directory or in this directory, then you know ahead of time how long it's going to be cached for. We kept all the tunable options at the origin, especially the TTLs. I know a lot of people, what they do is they have Akamai or they have their TTL configuration at the CDN level. We decided to tell the CDN, hey, obey cache control headers from the origin. What this does is that if in an emergency we need to turn the TTLs up, we can do that at the origin right away without having to wait for the CDN to propagate a new config to their network. So let's say, for example, we want to change our 30-second TTL to a minute. We can just go ahead and make the Apache config change to 1 minute, and then once that 30-second TTL expires at the edge, when they come back to revalidate that object, they'll get a new cache control header that says caches for 1 minute. So it's instantaneous. And then the last thing that we did was we moved any personalization onto the client side. So an example of this would be, instead of requesting a page that contained all of your personalization, the way that where you want your news or what kind of news that you want, we decided to store that information in a cookie instead and use JavaScript to assemble the page on the client side. So from 2003 to 2010, we didn't need to change anything. But in 2010, we upgraded our origin infrastructure, faster CPUs, and we decided to add 3 more machines. Even now today, the CPU utilization is still hovering around 50%. And it only cost us $15,000 to roll this out. So it was cheap. Management was happy that we weren't spending hundreds of thousands of dollars or millions of dollars to roll out a new infrastructure. So here's a graph that shows today our bandwidth offload to the CDN. So it's 93–95% of our traffic is handled by the CDN. On the hit side, it's a little bit lower at 80%. And this is because our TTL is so low. You know, the edge still has to come back to us for all those if modified since requests. But we save a lot on bandwidth. We save 95–93% on bandwidth because of that, because we're not sending that full payload back to the edge. So how do we scale for unpredictable events? You know, the breaking news events. Well, we rely on the fact that checking the last time a file has changed is faster and quicker than delivering that file to the user. So like I said, we use conditional gets. We make sure users don't have to search for the content. More clicks on your site equals more traffic. So we want to make sure that any news or information that users are expecting to see is right there on the front page. We also changed the website a bit to be a little bit more lighter weight, less bytes to move. We haven't had to do this in a long time, but you know, we can increase our TTLs a bit. Even just if it's just an extra 10 seconds, you know, 10 seconds will reduce origin traffic quite a bit, but still, you know, keep your content fresh. It's only 10 seconds longer. And then of course, turn off dynamic components if you have any. Anything that relies on a sign-on or membership information, that kind of stuff. So scaling for predictable events is a little bit more difficult. We haven't been able to accurately predict over the past 10 years with how much a specific event will generate in traffic. In fact, it's kind of funny, for every major event, whether it's the NHL playoffs or you know, the Olympics, we have an office pool, whiteboard. Everyone marks, you know, what our peak traffic is going to be during this event, because it really is, no one knows what it's going to be. But we do use a few guidelines based on our previous experience. So one thing we've noticed is that scheduled events never peak as high as unpredictable ones. So let's use Whitney Houston's death, for example. We will never, ever, ever hit 14 gigabits per second for a scheduled event. And you know, that's been true for the past 10 years. And partially because scheduled events last longer, and that increase in traffic is usually spread out over hours or days. And then they are also more, I like to call them niche. You know, breaking news, everybody wants to know what's going on. But you know, NHL playoffs, only hockey fans want to come to your site. So that sort of scales down the number of people who are visiting. One thing that we did obviously have to keep in mind is bandwidth. So because this is stretched over a longer period of time, you're not going to get the advantages of 95th percentile billing as much. You know, the spikes usually get chopped off with 95.5 billing, but if that's, you know, stretched over days or weeks, you know, the Olympics is 2 weeks, then usually our bandwidth bill goes up quite a bit. So as I mentioned earlier on, you know, our website is mainly read operations. People come to read our news. So how do we handle situations where we need to write to the website? So in 2008, we added commenting. Users are able to comment on news stories now. And what we decided to do was let somebody else deal with it. You know, there's a lot of SaaS services out there. We use a company called Viafora for commenting, PollDaddy for polls, Omniture for analytics, and we pay them lots of money so that they don't go down, and people can still comment on our website. You know, that's, like I mentioned earlier, our core business really is journalism. We're here to write news and get the news out. We didn't decide to expand our development team to be able to, you know, add the commenting functionality. We said, hey, let's just pay the money for another company to deal with. So, I know this is a short talk because I want to get out of here before 5:30. So I'll summarize for you. Ensure your TTLs are appropriate. Make sure that your applications return last modified headers. Unless you specifically program in last modified headers into, like, say, a PHP script, requests for that object is never going to return last modified header. So, double check to make sure that you're doing that. Don't be afraid to turn off site components that aren't critical during high traffic periods. Keep your tunables at the origin. And keep in mind that a CDN won't fix a bad or broken infrastructure at your origin. During this whole chain, if your weakest link is the origin, then your CDN isn't going to magically fix that. Predicting the scale of a scheduled event is relatively impossible. You'll either over or underestimate. I guess it's better to over than to underestimate. But you can take a look at your previous traffic levels during unscheduled events, if you have any, and use those as a high watermark. And then don't be afraid to ask someone else to implement a feature that's not your core business or expertise. When we decided to go with the commenting SaaS provider, a lot of the developers internally were hurt. Why are we here if you're just going to outsource everything? But management convinced them that this is a good idea and that they can concentrate on making sure that our core business, delivering news, is done properly. I go into a lot more technical detail as to how we set up the server-side includes, and we call them story templates or story wrappers in a paper I published to Usenix last year. There's the URL. And if there's any questions, I'll take some now. Yep.
Did you have to support paywalls?
No. So one of the good things about being a media organization owned by the government is that the populace of Canada owns us, right? So if we were to put a paywall up, a lot of people wouldn't be happy, unlike private media. So we didn't have to worry about that at all. Yeah. Yep.
You said server-side includes, was that Apache?
Mm-hmm. Yep, so Apache is processing those SSIs. We like them better than using, like, say, PHP includes, because you can't execute any arbitrary code, right? You can't shell out, you can't do anything. All you can do is simple file includes and a few outputs. That's about it. Yeah. Yep.
Do you consider using edge server includes?
Yep. So just recently we started using ESIs for device detection. So what we wanted to do is we wanted to provide a different front-end experience to mobile users. And because not all requests will make it back to the origin, we need to do that sort of device detection at the edge. So we use ESIs heavily for that based on user agent. So there's a snippet of ESI code at the top of all of our pages that says, hey, if you're a mobile browser, go to /m or whatever the mobile web URL is. One thing that we did do that's kind of interesting is that we have that ESI code at the top is actually included by an SSI. So we're getting kind of into an exception thing here, but if we ever need to make changes to that ESI code, we just need to edit that one SSI file, or that one file that's SSI included at the top of the page, and that's managed by a completely separate group in the company. So it was kind of the developers had to get their head wrapped around the order of processing. SSIs got processed first, then it went to the edge, then ESIs got processed, and then it went out to the client. So, yeah. Yep.
You're mentioning that you want to have everything in the origin, with the obvious exceptions, which was an example. But it'd be interesting to hear some of the reasons why people would, or why, when you were making that decision, whether there was anything that you said, well, we're going to give up a bunch of data images.
So are you talking about the control of the cache times and stuff at the origin? And you're saying that there's, I'm still trying to understand your question.
Well, is there a trade-off? There must be a trade-off.
Mm-hmm.
Because actually, I'm from lower than stack, right? So
Right.
I'm always mystified why the CDNs have these controls out there when it seems to me you've got an origin
Yeah.
So there must be some reason. I'm wondering.
But there must be some reason why the CDNs have the control. I have no idea. We don't use it, right? I didn't see an advantage to doing that either, right? The guys know Apache. They know mod includes. They know mod headers. That's an advantage to keep it at the origin. Being able to change it quickly without having to wait for propagation, through the CDN is another advantage at the origin. I don't understand why they do that. Maybe it's just to fill their feature sheet, yeah. Yeah.
You mentioned that you really don't want to delete anything. You want to be able to historically get everything.
Mm-hmm.
As that site grows, is there some, at least recently used offlining of some of this so that you have a separate set of servers for that?
Yeah. Yeah. So we have a whole department called the archive department. So there's a huge debate internally as to whether news should ever be archived to this other system. Big major events usually are archived as like the archive website's like a museum, an online museum. So you can go and click on major events that happened throughout history, World War II, and the specific pieces of site content are included in there. And I don't know why, I'm not a journalist, but they don't want to do that with their specific news stories. They want to make sure that if I type in, something that happened, 50 years ago, or maybe not that long, 15 years ago, that any news articles about that are still on the site for them for users to read. My biggest problem is that back in 1995, we didn't write news for the web. We just took what scripts people were saying on television and published them to the web. So it's not, a media organization that's built around television and radio and not print. The content back then isn't really as relevant as it could have been. So I always challenge on a daily basis. Why do we have stuff from 95 when it's at the very end of the long tail, no one reads it, the content isn't very good, and it's just taking up precious disk space, right? So, they believe it's an editorial decision and not a technology or a system inside decision, so I can't really argue with that.
That's
Yeah.
20 years down the road, are you going to have to architect your disk space that's accessible from your main tier origin servers?
Perhaps. Text doesn't take up a lot of space, and it's pretty lightweight. So we do have a two-tier system for media versus non-media, but I don't foresee us having to do that, 10, 15 years down the road. Yeah. Yep.
You guys have made the decision to outsource, like commenting and whatnot. Does that end up trapping a component of y'all's website to a company that if you were to leave, it is no longer, the comments are gone forever?
Yeah, and it's funny that you mentioned that because we just transitioned to VIA4 from a previous company last month. And there's some definite technical challenges around that. The previous company used the URL as the key for the comments. So our URLs can never change now, ever, right? Or our comments will magically disappear. So we have a bunch of redirects, like about 800 or so of them, to make sure that users are always sent to the right URL. The good news is that the previous company that we were using was able to export all the comments into a format that this new company was able to import in. So the transition was relatively straightforward, but the fact that the URLs have to remain the same is challenging, especially during site redesigns and whatnot. Yeah. If there's nothing else, thank you very much.